So we've been learning about place value. Every place has a value, and we keep track of these things. And here's how we do it. Here's the convention that humans have created. This website, by the way, is a link in the Google slide. You should be able to see it, and you can jump on and play with this too, this base 10 block thing. And so way over here on the right, we keep track of single, in this case, we're going to use these blue blocks. And because we have in our base 10 system, we have 10 symbols, 0 through 9. There's 10 symbols, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 0 through 9. So as long as we have less than 10 blocks, I can put the appropriate symbol to keep track of how many blue blocks I have in this area. If I had 1, I'd use the symbol for 1, for 2, for 3, and as long as I have 4 or 5 or 6 or 7, hang in there, or 8 or even 9, all is well. But as soon as I get to 10 blue blocks, I can no longer keep track. In fact, let me just write down what I've been keeping track of. In this column, we're keeping track of what we call the ones. So it's the ones place because we're keeping track of one single blocks. But as soon as we get to more than 10 blocks, we have no symbols to use to represent those blocks. We have to take all those blocks and we have to group them. It won't let me. Huh. Oh, it did. And move them over to the tens place. I was expecting it to make it into a 10. We have to move them over to the tens place. So now we can keep track of how many groups of 10 we have. And so this next column is keeping track of how many bundles or how many groups of 10. There. All right. So what I'm going to do is get rid of these because rather than keeping track of these single groups of 10, we're just going to keep track of a 10. Now, in this column, I could have one group of 10, or I could have two groups of 10, or 3, or 4, or 5. Let me get them all up there. And as long as I had within 0 to 9 groups of these 10s, I could just put the appropriate symbol there. If I had one group of 10, I'd use the 1. Two groups of 10, I'd use the 2. 3, 4, 5, 6, 7, 8, or 9. But as soon as we got to 1, 2, 3, 4, 5, 6, 7, 2, 4, 7, 8, 9, 10, as soon as we got to 10 of these, I would have to bundle them and move them over to this column and start keeping track of 10 tens, which are 100s. And that's how this pattern goes. Now you can do this in any base system that you like. As you saw before, we were doing it with sonic numbers, which are really base 5. I did not invent sonic numbers as a brand new idea. They're just base 5 numbers. You can do this in any base that you want, but the idea is every time you run out of symbols, you've got to bundle and move over to the next place that has a new value. And so we would move over here to the 100s place. And if you had 10 100s, 10 100 would be 1,000. And this can go on and on and on as far to the left as you want to go. You guys know there's hundreds, thousands, and then 10,000s is 10,000. 10 10,000s is 100,000. 10 100,000s would be 1,000,000, and on and on and on and on and on. But ones, tens. Now, here's a cool thing about this. Because we're bundling at tens, what we're really saying is this. In this ones column, if you had 1, 2, 3, 4, 5, 6, 7, 8, or 9, you didn't have a bundle of 10 yet. So we could say this. You have 10 raised to the power of 0. That is, you have 0 full sets of 10. But as soon as you do have a full set of 10, you bundle them and move them over to the tens place. And so here in the tens place, let me get that out of the way, what you would have is single bundles of 10, 10 to the first power, the tens place. And if you got 10 tens, if you got 10 tens, that would be 100, and you'd start to keep track of hundreds, 10 squared. Notice, look at this picture. It's 10 by 10, 10 groups of 10, 10 times 10, 10 squared, 100. And as soon as you kept track of that, now this one you have to imagine, I don't have it to build on here, but imagine taking those sets of 10 and stacking them up. What you would have is a 10 by 10 by 10 cube. And so when you get to the 1000s, you'd be keeping track of 10 to the third power, or 10 cubed. And so powers of 10 is what we're seeing here as we move from right to left. Now I'm going to pause here, and I'm going to move into a little assignment here, and just for thinking, to be something to submit on Canvas later. But for immediate time, I just want you to think about what's happened here and think about how this would play out with any base system. You bundle when you run out of symbols. If it's base 5, like our sonic numbers, you bundled the ones into 5s. And then 5 5s were 25s. And then 5 25s was 125s. In this case, you bundle when you get to 10. So if you have singles and you get to 10s, you bundle and you start keeping track of 10s. And if you got 10 10s, 100. If you got 10 hundreds, thousands, etc., etc., etc. You could do this with any base system that you like. Think about it. I'm going to pause here. Keep going.